Hey everybody, and welcome back to the Foundations of Algebra course. Today's a really big day because we finally get a chance to talk about the essence of algebra. You guys remember that algebra is the study of the operations on the real numbers, and we spent the past 12 lessons talking about the real numbers. We know that they are the integers and all the numbers in between, and the operations. We know that there are only two, addition and multiplication. So we've got the operations, we got the real numbers, so we've got the operations on the real numbers. So we're done, right? What else is there to do? What more could algebra be about? Well, it turns out there's one thing we haven't highlighted in that statement, and that is the study. Algebra is the study of the operations on the real numbers. It's not only about just knowing how to perform the operations on the real numbers. You got that. That's great. But algebra is the study of the operations on the real numbers. And let me show you what I mean by that study. It's best done through an example. So, for example, let's say you've got 3 plus 3. You know that that's 6. But if you study that a little bit more, look a little deeper, you notice that 6 is really 2 times 3. If you have 8 plus 8, that's of course 16. But if you look more closely, you see, all right, that's 2 times 8. 16 is just 2 times 8. 41 plus 41, well, that's 82. And looking a little deeper, studying it some more, you notice that that's 2 times 41. And after you do a bunch of these, you start to recognize some patterns and some connections here. It doesn't look like there's anything special about 3 and 8 and 41. In fact, any number, any real number, plus itself is going to equal 2 times that number. That is a connection between addition and multiplication that algebra sort of brings to light by studying those operations. Let me give you another one. If you had 3 times the quantity 5 plus 2, we know how to do those operations with our order. We're going to go inside the parentheses first. 5 plus 2 is 7. All right, so 3 times 7, that's 21. But if you look a little bit more deeply, if you study that some more, 21 is really 3 times 5 plus 6. That's not as obvious as our first example, but I'll give you a second to verify. You believe me on that? That's 21. Good. Remember, multiplication first before addition. What if we looked at this example? This time it's 3 times the quantity 7 plus 2. All right, well, inside is 9, so 3 times 9 is 27. If you look a little deeper, that's 3 times 7 plus 6. One more. If we now do 3 times the quantity 10 plus 2, so 12, 3 times 12 is 36, and that's 3 times 10 plus 6. So you can do some more examples if you're not quite seeing the pattern or the connection, but what it turns out is that 3 times the quantity any number plus 2 is just going to equal 3 times that number plus 6. So those are the kind of facts, the kind of things that we study and the facts that they generate through algebra. So here, one quick thing. Writing those statements, any number plus itself equals 2 times that number, that's a lot. We introduce a notion of a variable. So we're going to pick a letter to stand for that number. Like here, for example, in the first one, any number plus itself equals 2 times that number. Well, if we just let x, that's the typical letter we use to stand for that number, that any number plus itself is 2 times that number. All right? And just like in the first one, in the second example, if we, instead of writing any number and that number, mathematicians don't want to write anything that they don't have to, and they want to keep things concise. So as you get into higher level mathematics, that's what we do. So we would replace the any number and that number, remember they're talking about the same number, with x. So we would write it like that. So there's the statement in algebraic terms. All right. So again, those are the facts. Those are the facts that algebra illuminates for us. And it turns out that for the most part, you're going to see most of the facts that we come up with, it's going to be saying like this thing equals that thing. And like the one we just saw. So you should know that each of those things, the thing on the left and that thing on the right, they have names. They're called algebraic expressions. All right. And just simply put, algebraic expressions are just a bunch of numbers, variables, operations, all lumped together. All right. Like, for example, 2x. That's an algebraic expression. See, it's a mix of a number and variable and an operation. There's really multiplication going on there. A 3x squared plus 6. That's a nice algebraic expression. They can get crazy, like 4x plus 9 all over x times the quantity x squared plus 3. That's a nice algebraic expression. But what's really important to remember is algebraic expressions are a mix of numbers, variables, operations, etc. But they represent numbers. They represent numbers. When you pick a specific value for x, plug it in, then that expression is going to be a specific number. So expressions, in the end, they represent numbers. You just have to tell them the x value, all right? So that's called evaluating. When you figure out what number that expression is, when you pick that specific x value, we call that evaluating an algebraic expression. So, for example, let's say you want to evaluate the algebraic expression 5x minus 4 when x equals 3. All right, so all you do is you just, wherever you see the x, you pop in the 3. So we would have 5 times 3 minus 4. And now we just simplify using our order of operations, right? And we're going to do, I see multiplication and subtraction, so we'll do the multiplication first. It's 15 minus 4. And then 15 minus 4 is 11. We got it. So that expression, 5x minus 4, when x is 3, really represents the number 11. Okay? Here's another one. Let's say you wanted to evaluate 3x squared plus 8, that expression, when where x is negative 2. All right, well, just pop in the negative 2 wherever you see an x, like that. So 3 times, I put a set of parentheses around there. That turns out to be pretty important because whatever else is going on around that x, that's got to be preserved. So 3 times negative 2 squared plus 8. All right. Now with our order of operations, what do we do first? Yell it out. Wait, I'm sorry. Let me give you choices. I see parentheses. I see exponents. I see multiplication, addition. Man, we got a lot of stuff happening here. Where do we go first? Parentheses. Good. All right. So there's not really anything to do in there. It's just negative 2. All right, cool. Now we go out to exponents. Nice. Man, you're on it today. Negative 2 squared is 4. So that's going to be 3 times 4 plus 8. And now multiplication and addition, we do multiplication first. 12 plus 8, 20. Game over. We got it. All right. One more, just to make sure. We've got we're being asked to evaluate x plus 5 over x, where x is 1/2. All right, well, you know the drill. Just pop in 1/2 wherever you see an x, and here we got 2 of them. So we got 1/2 plus 5 over 1/2. And let's go ahead and simplify. Let's see what this ends up being. The fraction, it's sort of 2 groupings together. There's a top, a numerator, and a denominator. So I'm just going to do the numerator. 1/2 plus 5. So, all right, I got to do that addition, but I can't add them because they're not the same things at the moment. So we get a CD, add them together. It's 11/2 divided by 1/2 or over 1/2. And you know dividing by 1/2 is the same as multiplying by its reciprocal, 2. And if you multiply those 2 guys together, you end up with 11. All right, so there it is. There's that expression that's the value of that expression when x equals 1/2. Looking okay? All right, so as I've mentioned repeatedly in this lesson, the kind of algebraic facts are typically this expression equals this expression, all right? And what's really important to realize there is that when you say a fact like that, like for example, 2x plus 3x equals 5x, or x times the quantity x plus 1 equals x squared plus x. Those are some facts that we'll develop later. Don't worry about them. I just kind of threw them out there. What it means when they write that and they say this is a fact, that means that those have to be true no matter what value of x you plug in. And by true, meaning whatever you get on the left is going to be the same as whatever you get on the right, the same number. All right. Tell you what, let's go back to our very first algebraic fact that we sort of guessed at by looking at those patterns. X plus x equals 2x, right? If that is a fact, and it is, then it has to work no matter what value of x you choose to plug in, right? So, like for example, if we plugged in 14, 14 plus 14, that's the left side, equals 2 times 14. All right, well, on the left, 14 plus 14 is 28, and 2 times 14, well, it's also 28. Yeah, that's true. That's true. What we just did is called a number test, all right, a number test. So when somebody proposes that something might be a fact, that this equals this, one expression equals another, or you yourself are saying that, well, I think that this expression really equals this expression. Remember, it's got to work for all numbers. So the way you can check, just to see if it's reasonable, we call it a number test, all right? Let me show you how it works. Here's an example. Let's say someone comes up to you and says, hey, I think this might be a fact. X times the quantity x plus 3 equals x squared plus 3. Well, the way you check it is you take any number you want. Don't pick 0. 0 is not a great number test candidate for some different reasons. Don't worry about it. Just pick a nice number like 2. Let's say we plug in 2 wherever we see an x in this statement. So every place you saw an x, I replaced it with a 2. Let's figure out what the left side gives us and what the right side gives us. Well, we got to do the parentheses first on the left. That's 5, so 2 times 5. And on the right, we got to do the exponents first, so 4 plus 3. And then 2 times 5 on the left, that's 10. And on the right, we get 7. But guys, 10 is not equal to 7. That is false. So what that tells us is no, that original statement, x times the quantity x plus 3 equals x squared plus 3, that is not true. That is not true for all numbers. So that's not a fact, okay? If you plug in a number and what you get on the left is not the same number as what you get on the right, then those two expressions, the original one, they're not equal to each other, all right? How about this? Let's say, someone else says, you know what, I think this is the fact. Well, again, let's just plug in a number, not 0, and test. Let's pick a nice number like 2 again. If we plug in 2, we already did the left side, right? We know that that's 10, 2 times 5. The right side is now 4 plus 6. 3 times 2 is 6. And 2 times 5 we know is 10, and the right side is 10. You know what? That worked out. When x is 2, yep, that left side does equal the right side. So what we can say is that original statement, that original proposed fact, is that it's probably true. It's probably true that x times the quantity x plus 3 equals x squared plus 3x. We can't say it's true because it has to work for all numbers. And we didn't check all real numbers. We only just checked one. But it's probably true. All right? It's probably true. And we'll talk about that issue later. But if you do the number test, plug in a nice number, not 0. Plug in a number. If it does give you a true statement, then the fact is probably true. All right? All right, guys, that was a lot, but it was super cool stuff, right? I hope you're getting a nice sense of the essence of algebra. We will continue that in our next lesson. Take care, guys.